Welcome to 6WIN's vRouter webinar, where we will present our Turbo CG-NAT vRouter, which is now generally available. My name is Kelly LeBlanc. I run 6WIN's marketing program and am based in Santa Clara, California. Joining me is Jan Rappaport, 6WIN's VP of Product Management. Jan will show a demo of our Turbo CG-NAT vRouter. We will conclude with a Q&A. Please use the Q&A button at the bottom of your screen to submit your questions, and we will answer them in the order that they are received. First, let me start with a quick introduction of 6WIN. 6WIN is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom, including source code for Linux networking and vRouters. In recognition of our innovation, we received an investment from Cisco and a vRouter Innovators Award from IDC. Here's an overview of our vRouter product portfolio. We have vRouter appliances and vRouters for hypervisors. 6WIN Virtual Accelerator is a vRouter for hypervisors that fulfills all the requirements to power the hypervisor with the necessary features for virtual networking infrastructure. This vRouter is used by Nuage Networks in their AVRS product. 6WIN Turbo Router, Turbo IPsec, and our new Turbo CG-NAT are vRouters in the form of software appliances that lead the market with a performance advantage. Popular use cases include border routers, IPsec VPN gateways, security for mobile infrastructure, Carrier Grade NAT, and more. Today we will focus on our Turbo CG-NAT vRouter. Here's a list of some of our key customers, many of which are brand names in the networking and applications market. OEMs such as Cisco, Nokia, NEC, Mavenir, Nuage, and many others have been using our 6WIN software to build their own products for over a decade. Service providers and enterprises such as Arbor Networks, AT&T, and Bloomberg use our vRouters to replace hardware routers in their networks. In today's webinar, we will start with an overview of our Turbo CG-NAT vRouter, followed by a demo. At the end, we have time for Q&A. Let's get started. Let me start with a quick overview of CG-NAT, also known as Carrier Grade NAT or Large-Scale NAT. Carrier Grade NAT helps ISPs with IPv4 resource conservation by sharing an outside IP address among multiple inside local private IP addresses. Benefits include the ability to use a pool of public IP addresses instead of one, the ability to limit resource usage per user, in addition to transparent translation schemes. 6WIN's Turbo CG-NAT is a high-performance software alternative to hardware-based CG-NAT solutions for ISPs who are looking to increase flexibility and lower costs. It is a high-performance CG-NAT vRouter solution for white box networking. Here's an example Turbo CG-NAT vRouter use case for one of our top-tier ISP customers. This ISP is an innovator to run CG-NAT services and virtual machines on Intel-based servers versus deploying standard hardware. As a result, they reduced their CapEx by 70%. With 6WIN CG-NAT software, our customer can support more than 30 million concurrent sessions with a creation rate of 200,000 sessions per second. Regarding features, we support the required networking protocols in our vRouter form factor to run high-performance CG-NAT solutions on Intel-based servers. The features highlighted in the gray box include our specific Turbo CG-NAT features. This includes NAT 4.4, NAT 6.4, port assignment, IP pool management, logging, ALG support, hairpinning, mapping, filtering, and more. Now let's see how easy it is to deploy our Turbo CG-NAT vRouter, both bare metal and in virtual machines. 6WIN allows you to easily build vRouter solutions on commercial off-the-shelf servers. We support a range of powerful Intel CPUs from the Atom processor all the way up to the latest Xeon scalable processors and 1 to 100 gig NICs. You can run our vRouter on top of Linux KVM, VMware ESXi, and AWS VMs today. VirtIO, VMXNet3, and SRIOV are supported. Many of you already have Intel-based servers from one of these leading vendors, so you're ready to go. Just download our software, and you can have a router with 1 to 100 gigs of throughput performance according to your requirements. If you are purchasing servers for your deployment, you have a wide range of options and flexibility for bare metal and virtual machine deployments. We license our Turbo CG-NAT vRouter with 1 gig to 100 gig options plus the number of connections that you required for CG-NAT. Now for deployment options for 6WIN Turbo CG-NAT, which is the same for all 6WIN vRouter products. Here we see 6WIN's Turbo CG-NAT deployed bare metal on COTS servers or within virtual machines. Within VMs, there are 3 options with varying levels of performance. The first is on top of standard open source hypervisor infrastructure using Open vSwitch or Linux Bridge with hypervisor options including Linux KVM, VMware ESXi, and Amazon Web Services. The second leverages hypervisor bypass technologies such as SRIOV or PCI pass-through, which dedicate hardware resources to virtual machines for the highest performance, but loses some of the benefits of virtualization, such as live migration. The third runs on top of 6WIN's Virtual Accelerator vRouter in the Linux KVM hypervisor domain for the best NFV-ready performance with 0 hardware dependence. Performance is close to bare metal, and virtualization features are preserved. We give you these different deployment options so you can make incremental software upgrades for your cloud transition. Remember, it's the same 6WIN software for bare metal or virtual deployments. 6WIN's vRouter brings our pedigree of scalable software performance to CG-NAT use cases. Here you can see our benchmarks on dual Xeon Platinum 8170 processors. We deliver 30 million simultaneous connections per 25 gigs of RAM, 200,000 connections per second per core, and 10 gigabits per second per core. 6WIN software scales linearly with the number of cores. If you need more performance, simply add more cores to the configuration. Once again, this is a testament to the power of white box networking. Now a word about management. The vRouter comes with an industry standard CLI, including help and completion. The CLI is organized in context and can be browsed in the same way as a file system. Here is a very simple CG-NAT configuration example. We see the pool of public IP addresses with the port range and block size, a rule to match incoming packets from the LAN based on IP address and NAT them towards the WAN, and a set of contract options to fine-tune the behavior of the CG-NAT. The vRouter management is based on NETCONF and Yang, and the CLI is actually a NETCONF client. Here's the same configuration in XML, as sent from the CLI to the NETCONF server. You can see here the same information about the CG-NAT pool, rule, and tuning options. NETCONF is a standard for integration with third-party management frameworks, and it is the API for an automated programmatic configuration of the vRouter. Regarding monitoring, Turbo CG-NAT supports monitoring through the CLI or NETCONF in order to dump CG-NAT statistics, including high-level counters, allocation errors, per pool and per rule counters in order to optimize the CG-NAT configuration according to the user traffic. The goal is to minimize the number of public IP addresses used while maximizing the services, that is the number of ports available to users. In addition to granular monitoring, Yang-based KPIs are provided for streaming to a time series database. This allows you to track statistics against time and therefore get a thorough understanding of the system dynamics to better optimize the configuration. The time series information can be displayed in a graphical analytics framework. As an example, we have pre-integrated Turbo CG-NAT with the InfluxDB time series database and the Grafana analytics framework. We track system information such as CPU usage, memory, network interfaces and their throughput, CG-NAT statistics, and more. InfluxDB Grafana is just an example of integration, and the same APIs can be used for integration with other frameworks such as Elastic, Prometheus, and more. Let's conclude our review of the main Turbo CG-NAT features with logging. It is a legal requirement for an ISP to be able to provide the mapping between a user and a public IP address at any given point in time. When millions of connections are involved, it's just useless to try to log them one by one. That's why Turbo CG-NAT comes with a compact log feature that consists in logging allocation of blocks. The logs can be retrieved into a logging framework such as Elastic's Logstash to parse them and be able to perform efficient searches. Jan will illustrate this in our demo in a few minutes. I will now turn it over to Jan.
Thank you, Kelly. Let me start with an overview of our demo. This is our demo platform with Turbo CG-NAT standing in the ISP's core network between the customers and internet. The customers are varied, including homes, enterprises, and universities, and the services they access can be web browsing, file servers, streaming or cloud services, and more, resulting in millions of simultaneous connections. This is the addressing scheme for our demo, and we run Turbo CG-NAT as a VM on 2 cores of a single socket Xeon E5-2697V2 CPU, and we use a Nexia XT80 traffic generator to simulate the customers and internet services. Let's start by reviewing the CG-NAT configuration using the CLI. Using the showconfig command, we can dump the interfaces, showing 2 interfaces connected to the LAN, 2 connected to the WAN, and 1 for the management. By using 2 pairs of 10 gig interfaces, we will be able to demonstrate 20 gigabit per second of traffic. Now, let's check the routing configuration. In this case, it is very simple, with static routes used towards the private and public networks. Black hole routes are responsible for dropping the incoming public traffic that doesn't match an existing connection. Next comes the CG-NAT configuration itself. In our case, we have 2 pools of public IP addresses configured with their block size and port range. Rules are responsible for matching the LAN networks according to the source IP address and NATing them through the corresponding WAN interface using the right pool. Rules also include per-user configuration information, such as maximum number of blocks and endpoint filtering scheme. Finally, global options for the management of connections are configured. In our case, the timeout of connections is tuned for the purpose of benchmarking. We can see as well that logging is enabled. We can check the equivalent configuration in XML format, which is what a NETCONF client would send to the vRouter to configure it in a programmatic way. We see the routes, the rules and pools, the CG-NAT global options, etc. Let's now switch to the Nexia traffic generator. This is the configuration screen for the IXload software, where we see the HTTP clients on the left connected to the LAN interfaces of the vRouter, and the corresponding servers on the right connected to the WAN interfaces. This simulates the customers on the LAN side and the internet services on the WAN side. In this first test, we have configured the Nexia to reach 10 million connections and maximize the number of connections per second, using a minimum HTTP page size of 1 byte. Ixia starts by establishing connections at a fixed rate, and then opens and closes connections continuously while transferring traffic to reach a maximum number of around 370K CPS with this 2-cores configuration. The throughput is not maximized in this case, as we use a small page size. Let's now have a look at the KPIs in the CLI. These key performance indicators include product information, such as license and version, system information, such as CPU or memory usage, networking statistics, including CG-NAT, and others. These are streamed from the vRouter to an InfluxDB time series database to be displayed in a Grafana analytics dashboard for a better analysis of the dynamics of the system. We can see the CG-NAT statistics evolve over time while the traffic is running. The CG-NAT filling section includes information about the status of the CG-NAT blocks, contracts, CPEs, and NAT session tables. The blocks and CPEs section shows the total number of blocks allocated and CPEs, their rate of creation, and possible allocation errors. The same information is displayed for actual sessions or contracts in the section below. All these statistics are very useful to adapt the configuration of the system to the actual traffic and tune the total number of blocks per CPEs, the public IP pools, and the port ranges to minimize the number of public IP addresses used while maximizing the services offered to customers. Scrolling through the dashboard, we can see the throughput on the interfaces. It is quite low in this case, as the goal was to maximize the CPS. We can also see disk and process usage, and back up in the dashboard, we see total RAM and CPU usage. Back to the CG-NAT counters, we see our max CPS number of 370K. Let's now quickly switch to an Ixia throughput test. The Ixia is configured to reach 10 million connections per second, this time maximizing the throughput. Traffic is injected as soon as the 10 million connections are established, using pages of 32 kilobytes. This results in a maximized throughput of 20 gigabit per second with our 2-cores configuration. During this test, the Grafana dashboard shows that the interfaces are running at higher speed on both the LAN and WAN sides. Now let's move on to the CG-NAT logs. We can dump them from the CLI and see the new block allocations with the private IP address, public address in the pool, and port range. It is also possible to filter the output on a single IP address using the map feature of the CLI. However, the amount of logs available in the system is quickly limited by the disk space, and it is preferable to integrate the logs with a more complete logging framework. For this demo, we have integrated the vRouter with Logstash and Kibana from the Elastic Stack. We can see the timestamp, the type of action, the private IP address, protocol, public IP address, and port range. Using a Kibana filter, we can see, for example, all block creations. Another more advanced filter will give us the logs for a single IP address and port, which gives the corresponding private IP address in case the ISP gets a request from the authorities, for example. To conclude this demo, let's have a look at advanced CG-NAT show commands in the CLI. Commands help fine-tune the CG-NAT configuration. The first one provides high-level counters, including packets passed and blocks, hairpinning, NAT and CG-NAT entries with port block allocations and invalid cases. Another one gives the status of the CG-NAT tables. command is available to show statistics per rule with block allocation per protocol, port, block, and public IP allocation errors. Another one shows contracts per user, including private source IP and port, protocol, public IP and destination port, and contract state. And the last three provide detailed port and block allocation statistics per rule and block allocation statistics per pool. This concludes my CG-NAT vRouter demo. You can see the power and flexibility of our software-based Carrier Grade NAT solution as an alternative to hardware. Now, I'll hand it back to Kelly.
Thank you, Jan. That was a very nice demo. For those of you that are interested to try for yourself, you can start your evaluation today. The process is very simple. Just click on the evaluation button through any page on our website and select Turbo CG-NAT. You will receive an automatic download for our standard vRouter so that you can get a feel for our software, and a 6WIND representative will be in touch with you to add the CG-NAT functionality to your evaluation. You also have the following links to check, including our product information page, a deployment guide to get you started, and a nice blog with intel that explains the benefits of vRouters for CG-NAT. Okay, so now we can see that there are some questions coming in. So let's open it up to Q&A. Remember to use the Q&A button at the bottom of your screen to submit your question. So let's start at the top. The first question: how do you license your Turbo CG-NAT vRouter?
So that's easy. We license according to the throughput and the number of connections requirements.
Okay, great. Second question: what's the performance of your CG-NAT vRouter?
So we have measured on a very high-end Intel Dual Xeon Platinum 8170. We have measured up to 30 million connections for 25 gig of RAM that scales with memory. We have measured 200K connections per second per core that scales with the number of cores, and 10 gigabit per second per core scaling with the number of cores as well. And what we demonstrated in this demo on a less powerful platform are 10 million connections, 370,000 connections per second, and 20 gigabit per second, all this using 2 cores.
Thank you, great. Okay, this is an interesting question. So what features did you add based on your beta feedback? So as a reminder, we've been having a beta program for the last several months, and with this webinar, we're now in general availability. So Jan, can you comment on the beta feedback?
Yes, sure. So it was an interesting session, between the beta and the GA release, we have included the configuration of the maximum number of sessions per user, and also the ability to share a pool between 2 rules. And we have also added to our roadmap deterministic NAT and NAT 6.4.
Okay, next question. Which virtual machines do you support?
So you can run all our vRouters on top of Linux KVM, VMware ESXi, and Amazon Web Services today. We support VirtIO, VMXNet3, SIRV, and PCI pass-through modes. And of course, as a reminder, you can also run our vRouters in bare metal. We are working on the roadmap on the support for containers, including Kubernetes and Docker.
Okay, so let's have a word about our NICs too. Can you describe what NICs we support? NIC support, yes.
Yeah, yes. So for bare metal, we support NICs from Intel, Mellanox, and Broadcom. So that stands for bare metal and actually SRIOV and PCI pass-through. And as I said, so VirtIO and VMXNet3 and AWS ENA are supported.
Okay, and this looks like the last question. So this is a common question we get. What kind of hardware do I need? Great question.
So you can run our vRouter on any Intel Xeon or Atom C3000 processor. So Xeon that includes E5, E7, scalable. So that helps to have a scalable solution according to your hardware. And if you already have one of these, you're ready to go. If not, you can easily find them through companies such as HPE, Dell, Advantech, Lanner, Supermicro, and more.
Okay, thank you, Jan. So that concludes our Q&A session. Okay, so thank you all for attending. Our webinar is now complete. Please don't hesitate to contact me directly if you have any further questions, and I look forward to hearing from you. Goodbye to all for now.